Let's continue our practice of the limits infinity minus infinity. Before we go to a limit which is of this type, let me just quickly revise what about this one. Limit for x going to infinity, e to the power of x plus x. Then, if x goes to infinity, this goes to infinity, this goes to infinity, and we have infinity plus infinity, which is infinity. Absolutely no problem, no derivative, no plus rule. What about e to x minus x? Then this is of the form infinity minus infinity. And that may be not so clear. One way is to factor out the most dominant term. Here we know that e to x goes faster than x, so we factor out e to x, and we are left with 1 minus x over e to x. So we want to find the limit of this fraction. We know already that exponential is faster than any polynomial, so we expect this to be 0. Let me compute this in more detail. Limit x divided by e to x, with x going to infinity. This goes to infinity, so we can try the L'Hopital's rule. And we have limit for x going to infinity, 1 divided by e to x, and 1 divided by infinity is indeed 0. So the original limit, let's call it capital L, is limit e to x minus x divided by e to x, but this goes to 0, and x approaching, e to x this way. This way. E to x times bracket 1 minus the fraction close. This goes to 0, so this bracket goes to 1. E to x alone goes to infinity, so we have infinity times 1, which is indeed infinity.